Hello everyone, welcome to today's math class. Today we have this nice exponential challenge. How do we solve this? It is easy. So let's take our solution. I solve a challenge of this kind, but I use a particular approach. In today's solving, I'm going to use another approach to solve this. So look at this power here and look at this power here. Here we are having 7 to the power of x plus 6, and here we are having 6 to the power of x plus 7. So the value of x that will satisfy this equation is what we want to solve for here now. We just have to rewrite this left hand side of the equation and the right hand side. According to the law of indices, it says that if you have your a all raised to the power of your m plus your n, this is same thing as your a to the power of your m times a to the power of your n. We all know this, right? So rewriting this is going to give us our 7 to the power of your x times 7 to the power of your 6 equal to this will give us x to the 6 to the power of x times 6 to the power of 7. So let's carry all the terms that are carrying variable, which is x, to the left hand side and the constant term to the right hand side. How do we achieve that? We're going to divide this by our 6 to the power of x times our 7 to the power of 6. Equally do same to this side. So we have 6 to the power of x times our 7 to the power of 6. So if you check this out, this and this will leave on this side, this and this will leave on this side. We are now left with 7 to the power of x all over 6 to the power of x equal to here we have 6 to the power of 7 all over 7 to the power of 6. If you check, the powers here are the same. So I want to achieve same thing here. I want to make the power here and the power here to be the same. And here, this is 7. I want to bring this 7 here as a power also. And so I can rewrite this side of this equation. So rewriting this is same thing as, let's keep this side our 7 rather, our 7 to the power of x all over 6 to the power of x is equal to 6 to the power of 7 all over 7 to the power of 7 times 7. This expression, if I use this to divide this, I will come up with 7 to the power of 6, right? So now that the powers are the same here and the power here are the same, we apply another law of indices. We say that if you have your a to the power of your m all over b to the power of your m, this is the same thing as your a all over b all raised to the power of your m. Okay, so apply that. This is going to give us our 7 all over 6 all raised to the power of x. This is equal to our 6 all over 7 all raised to the power of 7 times 7. Now, in that question, the one I solved in the other video, where I have a similar challenge of this kind, from here, I did a different manipulation from what I'm doing here now. Okay, so that is where the difference lies. These plaques here, I use another method to make the powers to be the same. But here, look at the method I applied here now. Now, the next thing we look at here is the base number to the power. Here we have 7 all over 6. Here we have 6 all over 7. So I want to twist this so that the base numbers will be the same. I'm going to apply a law which says that if you have your a all over your b all raised to the power of m, if I want to interchange the variables, then it's going to give me b all over my a all raised to minus m. The power will carry negative, all right? So doing that, this is going to give us here 7 all over 6 all raised to the power of x is equals to 7 all over 6 all raised to the power of minus 7 times 7. Easy. Okay. Now, if you look at this carefully, I want to eliminate these minus here. So how do we do that? There is a law again which says that if you have your 1 all over your a all over b all raised to the power of your m, this is equal to your a all over your b all raised to the power of your minus m. This is another law again. So we can rewrite this in this format. So this is going to give us something of this kind here. We're going to have here 7 all over 6 all raised to the power of x. This is equal to, here we're going to have 1 all over your 7 all over 6 all raised to the power of 7, then times our 7. Easy. So what we do next here is this. We have to eliminate this, and for us to eliminate this, we multiply this side by this quantity, multiply this side by this quantity. And so this is going to give us our 7 all over 6 all raised to the power of x times 7 all over 6 all raised to the power 7. This is equal to 1 all over 7 all over 6 all raised to the power 7 times our 7 all over 6 all raised to the power 7. So these and these will leave the system. The bases are the same according to this law again. So we can add the power. So we're going to have here 7 all over 6 all raised to the power of your x plus 7 is equal to 7. Easy. So the next thing we do here, we can ln both sides of the equation, or we can take log to base 10. But here, I want to do a simple manipulation. I want to take log to base 7 all over 6. So doing that, this is going to give us log our 7 all over 6 all raised to the power of x plus our 7 base 7 all over 6. This is equal to log 7 base 7 all over 6. Easy. So what happened? We apply a law which says that if you have log, your log, let's take a to the power of t, said move this back. So this is going to give us t times log a. So if we apply this law, we're going to move the whole of this backward here. So this is going to give us x plus our 7 times our log 7 all over 6 of the 7 all over 6. This is equal to our log 7 the 7 all over 6. Easy. Again, we apply what we call same base law. Same base law says that if you have your log a base a, this is equal to 1, provided a is not equal to 0. So if we apply this law again, this will give us 1. So we are now left with x plus our 7 is equal to log 7 is 7 all over 6. Easy. Now look at this. We are looking for s. So move this to this side of the equation. If we do that, this is going to give us our x will now be equal to our log 7 is 7 all over 6 is minus 7. This is the answer. For the case of your OBJ examination, if you do not see this, then we can simplify this down. And again, we cannot compute this in our calculator. So what we do, let's go ahead and simplify this down. Let's take from here. So here's going to give us x will now be equal to. The first thing we do here is to apply what we call change of base law. We change it to our natural base, which is base 10. Okay. The change of base law says that if you have your log, let's take if you have log a base b, this is equal to your log your a base c. We are changing it to base c. They're all over our log your b base c. So if we apply this law, we can rewrite this as our log 7 base 10. We are taking it to base 10. Okay, so all over our log 7 all over 6 base 10 minus our 7. Good. Now look at this other side. We have what we call the division law of logarithm. What does it say? It says that if you have your log your m all over n base 10, this is equal to your log your m, then minus your log your n. All right, so apply this to this side. This is going to give us here our log 7 base 10 all over our log 7 base 10 minus log 6 base 10 minus 7. Easy. Then, what happened? From here, let's look carefully. Remember, we can still simplify 6. 6 can be simplified into 2 times 3. So here, we're going to have this 2. And if we have this to be 2 times 3, we apply the multiplication law of logarithm. Okay? So the multiplication law of logarithm says that if you have your log, your m times your n, this is equal to your log, your m plus your log, your n. So if we apply this, after changing this, it's going to give us log our 7 base 10 then all over our log 7 base 10 then minus log 2 base 10, because here we have plus initially after changing it, and this minus is affecting everything. This will now give us here minus log 3 base 10. Then everything minus 7. Easy. Now look at this. If you do not see this again in the options, then you can simplify this again. This is all over divisible 1. So you find the LCM of everything, multiply out, and see what this gives us. So this is going to give us something of this kind here, because this now is the LCM. So this divided by itself will give us 1, times this is going to give us log our 7 base 10, then minus this minus here, which is this 7 times everything in here, right? So this is going to give us here minus 7 log 7 base 10. Then this very guy here now, because this is already minus, it will multiply this minus to give us plus. So we're going to have here plus. So we're still going to go with this 7 into this. So our plus 7 log 2 base 10. Then 7 with its minus sign multiplied by this will give us plus another 7 log 3 base 10. Everything all over log 7 base 10 minus log 2 base 10 minus log 3 base 10. Yeah, we're almost there. So this is log 7 base 10 minus 7 log 7 base 10. So we can simplify this, right? So if we do that, so this is going to give us here, this is, so we can say therefore our x will now be equal to, this is going to give us minus 6 log 7 base 10. Then this, here we have 7, here we have 7. We can factor out 7 from here. So plus 7 into our log 2 base 10. Write this very well. Base 10, then plus log 3 base 10. Close bracket, everything all over our log 7 base 10 minus log 2 base 10 minus log 3. So if you do not see this, you do not see this, you will see this. If you do not see this, you will see this, you will see this option. All right, so this brings us to the end of this smart class. Drop a comment in the comment section. See you in our next video.